Hello everyone. Welcome to the Efficiency for Access Design Challenge web series. Welcome back. We're excited to have you all today. If you are watching in the recording, some people will be joining the room shortly. My name is Sean. I'm on the Efficiency for Access Design Challenge team, and I'll be hosting this webinar today. I'm joined today by my colleagues Emil and Jackie, who will be supporting me, particularly through the chat. So as usual, a bit of housekeeping before we begin. I'm recording this webinar and its transcript, which will be available online. So if you do not wish to be recorded, please turn off your video and or mute yourself, and we'll share this recording and slides with you following the event. Today you'll be hearing from 3 speakers. When they're presenting, please turn off your videos and mute yourself to avoid any distractions. However, you're free to turn on both for our Q&A portion of the event. If you have any questions once the webinar is online, please just send them to Efficiency for Access Design Challenge email, which will be provided in the follow-up email and in the chat. Okay, so if you do have any questions live during the Q&A period, please raise your hand using the raising hand function at the bottom of the screen, and we'll call upon you. Additionally, the chat will be open to questions and comments from our audience throughout the event. They can be sent anonymously or to everyone, so I encourage your speakers to participate in the chat as well if they can. So today's panel is full of expertise and experience. So I would encourage everyone who can to ask as many questions as they can muster. So remember, this year's webinars are organized around the different elements of the assessment criteria, and so will be something you will have to address in your own design process. Today's session is our first in this series on innovation. Specifically, the question highlighted here, what is the potential of your design to improve energy efficiency compared to existing alternatives? Consider how you define energy efficiency and what the baseline is for comparison. So today we're going to be understanding the importance of efficiency, how efficiency can be achieved in your design, and how you might be able to begin to establish the market baseline on efficiency for your product. Efficiency considerations are a central column of the Efficiency for Access Design Challenge, judging by the title, of course, and it's laid out in our mission statement to encourage teams of university students to help to develop efficient off-grid appliances. And particularly the Efficiency for Access Coalition stipulates in our theory of change that efficiency is a key cornerstone to achieving further energy access and to reduce the cost. So this is the agenda for today. We only have about an hour for today's session. So we'll hear from 3 speakers followed by a Q&A portion, and then a few things to close up shop. So without further ado, let me introduce our speakers. Here we go. First, we'll be hearing from Mohammed Shehryar. Shehryar is the founder and managing director of Harness Energy. The company aims to provide reliable and affordable solar products, solar lanterns, home systems, and efficient appliances to low-income Pakistanis. Harness Energy works with multiple Verisol certified manufacturers and microfinance institutions to effectively deliver these products at the last mile. Shehryar has an MA in economics from Duke University on the Fulbright Scholarship and is an Acumen Pakistan Fellow. Apart from a passion for renewables, he is interested in cricket and astronomy. So welcome, Shehryar. Thanks for joining us today. Next, we'll be hearing from Mr. Mohammed Ershadullah. Ershadullah works in the field of renewable energy and energy efficiency with project work experience in Bangladesh, Myanmar, and parts of Africa. Mr. Ershadullah's professional experience includes receiving 2 Global Leap Awards in 2015 for an off-grid television, and in 2019 for 3 solar-powered water pumping applications, each based on appropriately designed high energy efficient appliance technologies to accelerate global energy access efforts. Currently, Mr. Ershadullah is the operations manager from Bengal Solar, a Bengal group of industries, one of the leading groups of companies in Bangladesh, with countrywide operations for distributing renewable energy related products and projects, where he specializes in engineering design, documentation, planning, and supervision for projects. His BSc is in applied physics, electronics, and communication engineering from the University of Dhaka, Bangladesh. He has a proven track record in designing and developing energy efficient products for both grid and off-grid areas, and a few of the products got extreme popularity. His innovations in the long run linked energy efficiency issues with successful business models. Finally, we'll hear from Richard Atwal from Renewit. Renewit designs and manufactures a range of solar-powered and lighting solutions. They've been developed to improve people's lives in areas of the world with little or no mains electricity. As well as their own product, they do OEM projects for leading companies in the solar field. Renewit are one of the most commercially minded and innovative off-grid technology manufacturers. They have a unique vertically integrated manufacturing capability, being part of a group of manufacturing companies producing LEDs, electronics, and smart technologies for industrialized as well as emerging and developing market applications. They are equally at home developing partnerships such as their facilitation of local assembly enterprises or commercially distribution partners. They are one of the leading manufacturers of solar solutions and also have a division that works on commercial solutions for businesses that need power for their business to succeed. This can include refrigeration for SMCG or drinks companies, or solar-powered retail kiosk for e-commerce and distribution companies. Okay, so welcome to all of our speakers. Thank you all for joining us today. So without further ado, we can move on. We're excited for the session planned for today, and I'll kick everything off with Shehryar. You want to take it away?
Thanks a lot, Sean. Yeah, so an advantage of going first is that you can sort of, highlight your worldview on the topic before everyone else does. So I think efficiency is a topic that's very close to my heart. Apart from going on to, appliances and innovation, the kind of stuff that we'll talk about later, I think there's a sort of there is an inbuilt desire that we have for efficiency, in a sense that, going back to our early history, what's the best way to catch that fish, how to better utilize your calories throughout the day. So I would say efficiency can be defined or viewed something as getting the best performance or the highest result out of using the lowest possible resources. So let's say, for example, if I want to, in today's environment, if I want to go from one point to the other, I generally use Google Maps, right? But I would also, before there were Google Maps, I would want to reach that place in the quickest possible time by using the quickest possible route, right? So that's efficiency. And Google Maps does that these days for us. And there's other examples. Let's say you invest your money in something, you want the best possible return on investment, right? So what is that if not efficiency? So like I said, getting the best possible outcome by using the least possible resources. So it is inbuilt into us. And I, from a very early age, I was a very, what would you like to call, like a proponent of using efficiency in, daily life. If let's say I have to attend a meeting and I'm stuck in traffic, I take a long route. So I'll be really frustrated about that. So bringing that thing to our business, I'll just highlight, how efficiency worked for us. Like Sean highlighted, are in a company called Harness Energy, and we provide solar solutions to low-income Pakistanis. And when you want to deliver the best possible impact in terms of, their energy needs, giving them lighting, mobile charging, and fans, if you are not using efficiency considerations in designing your solar systems, in designing your batteries, then your end customers will suffer. They are low-income customers, so their incomes will suffer, and ultimately, the business model doesn't make sense. But before moving on to what kind of things we sell and how we have incorporated efficiency into our solar products, there's a very good example that a lot of you might have heard of. IDCOL. So IDCOL was a solar financing program in Bangladesh that was funded by World Bank and other agencies. So I was looking at the presentation a few days ago that IDCOL initially started in 2005 and 6 with a 40 or 50 watt solar system, And with that 50-watt solar system, the customers usually got to run just 3 to 4 lights and charge their mobile. Now, of course, back then the prevalent lighting technology was CFL, like those energy savers, and they were using lead acid batteries. So it was pretty expensive back then. But right now, when I think about it, using 50 watts of power just to run 3 lights and charging a mobile phone is pretty crazy. Because right now, today, and we use this product as well these days, we can use 15, 12 or 15 watts, like 15 watts to run the same load, to run 3 or 4 lights and charge your mobile phone. Why? Because batteries, lead acid batteries, have been replaced by lithium-ion batteries that are much more efficient at storing energy, that are much better in terms of energy density, and we have moved on to CFL, from CFL lighting to LED lighting, which is much more efficient at delivering the same amount of light and lumens, but consuming a much lower power. And if we go back even from CFL, till probably the mid 90s, we had incandescent bulbs, that bulb that used to consume 60 or 80 watts of power. Now, today in 2021, we can deliver that same amount of light, that same amount of luminosity by consuming just 5 or 6 watts. So amazing efficiency improvements in lighting. So coming back to solar, we currently provide solar lanterns and solar home systems to our customers. And initially we started with solar lanterns, but then when we would go on to these villages and see, the energy needs of people, what they actually needed. So Pakistan is a really hot country, and people really want a fan in their home, a fan that can run for, 12, 15 hours a day so that they can sleep peacefully at night. And we saw that in the market, people were, getting these DC 12-volt fans that were consuming 35 or 40, 45 watts of power. And they were directly plugging in these, using these crocodile clips with, the lead acid batteries. So a massively oversized system, really inefficient fan. And then this used to really frustrate me, even though we were not offering fan-based solar home systems back then. But it was really frustrating for me because, like I told you, if I see something inefficient when an efficient alternative is available, it doesn't sit right with me. So we took a step. It was the first time we got into 50 watt. The first system we offered was a 50-watt solar system that I mentioned, a decade ago was being used in Bangladesh only to run 4 or 5 lights. We improved the efficiency of the motor. We asked our supplier to bring the power a bit lower, but they had their own constraints, so they could bring it to only to 28 to 30 watts. But we included LEDs in that. So in 50-watt system, we gave the customer an option to run their fan for 8 to 10 hours a day, which was a significant improvement for on what was available in the market. And while doing this, while we were selling this or doing this pilot of bigger systems, I figured out that there was some capacity issues with current fan manufacturers, and there was a hyper price competition, so that they were not willing to go the next step. So we applied for the efficiency for access grant for improved appliances, the cooling grant, and we were the only supplier amongst the shortlisted cohort to get a grant specifically on fans. So what we decided was we decided to introduce Pakistan's first solar fan that was powered by a BLDC motor. So a brushless motor, vast efficiency improvements over a normal motor, giving the same airflow, because we realized that could not be compromised in Pakistan. But so we brought down the efficiency or the power consumption of a DC fan from 40 watts to 18 to 20 watts. We could even go lower than that, and global leap awards show that fans have actually reached 10 to 12 watts of power consumption. But in Pakistan, there was a trade-off. We could not go lower than 18 to 20 watts, because then we would have to compromise on airflow, and that was something that our customers were not willing to accept. But even coming to 20 watts from 40 watts is a big efficiency improvement. So we were able to offer a higher number of hours to our customers. Then we went on to introduce an 80-watt system that was pretty much running the fan, the new fan, for about 10 hours every night. And our customers were really satisfied, and they were buying this system on installments. So anyway, so this was the journey that we went through. This happened in about 4 or 5 years. We realized what the customers were wanting, and then we sort of created this product in reverse. So we wanted, what kind of airflow they wanted, what kind of power we could give them, what kind of watt power that we could bring it to, and then we designed the product. And now I think coming back to the topic of why efficiency is so important in innovation. I think if you look at the industry that has revolutionized information technology in the last 20 years, mobile phones, smartphones. Like imagine it's a 4 Ah or 4000 mAh battery that can basically do everything you can imagine that was being done by Walkmans and calculators and speakers, even 20 years back. Because I follow this industry a lot, and I'm just amazed at what this low voltage technology and the efficiency improvements in speaker, microphone, radio, video viewing, LED OLED panels. So I think what smartphones have achieved in the past 15 years, that should be sort of our benchmark into how we can take this efficiency improvements into other sectors like appliances. Appliances, I mentioned, for lighting, from incandescent bulbs to CFL lighting to LED lighting, from fans, from basic, really heavy brush motors to BLDC motors. We have also seen now brushless motors being introduced into air conditioners and refrigerators. So what has all this done? All of this has enabled millions, like hundreds of millions of people from China and India and Pakistan to grow into the middle class, to buy these appliances for the first time, but consuming much, much less energy than what sort of their Western or the US or European counterparts did 50 years ago in the post-World War economy. So I would think that the progression into middle class that has been done by the East has been much cleaner compared to what it was done by the West, because the appliances are consuming much less energy, and hence when they consume less energy, you have to generate less energy from coal and oil and all that. So you see this whole value chain analysis of efficiency performance and how it actually goes down to the level of power generation. And I guess if you're a student and you're designing a new product, I think just going to perfect engineering, working everything perfectly, I think two considerations would be really important. First, the design should be human-centered. You should start with the end customer and their requirements, and then design your product according to their needs. And I think the other thing should be, what benefits are the end users getting? Is the ultimate product, when it's commercialized, will it be cheap? Will the customer save money? Especially if you're designing products for sort of so-called bottom of the pyramid or the global bottom 20% customers. So I would say whatever kind of product you're designing, specifically if it's related to energy consumption or if it is bundled with solar panels, I think these two considerations are very important. And I would just like to end my time by saying that we learned a lot from in the past 18 months from the Efficiency for Access project. And the great thing is so after developing this pedestal fan, solar pedestal fan with BLDC motors, now the next step that we're taking is we're using these we're moving on to air coolers that Mr. Irshad might know about. Bangladesh, Pakistan, India have these air coolers that are much cheaper than air conditioners, but that can cool the air. So we're taking our BLDC efficient technology from fans to air coolers, and we're hoping to commercialize them in the next couple of years, and let's see how things go. Thank you.
Thank you, Shehryar. Thank you. Yeah, great to hear what the kind of potential is for efficiency improvements as well. So set a benchmark of smartphones, I think is a high one, and it would be great to see appliances all kind of reach that level of efficiency. Thank you. And now we can move on to Mr. Irshad. So would you like to take it away now?
Hello everyone. I think, can you hear me clearly?
Yeah, we can hear you great.
Okay. I am MD Ershadullah from Bangladesh. I am working in the field of energy efficiency and sustainable energy for last 12 years. It's a great opportunity for me to meet you all in this program. I also thank the organizer for such great initiative. Today, I will try to speak about the importance of energy and innovation according to my professional experiences. Energy efficiency nowadays is the most important things that should be considered during innovation. We all know about the Moore's law. the number of integrated IC in a circuit, it is getting double in every 2 years. Nowadays, another law declared by Johnson Comey, a professor of Berkeley University, known as Comey's law, he stated the computable joule of energy dissipated double in every 1.57 years. The initial example he stated was at a fixed computing load, the amount of battery you need will fall by a factor of 2 every year and a half. This trend had been remarkably stable since 1950s. The future is energy efficiency. Future innovations are power efficient design. In semiconductor design, interframe power gating, voltage islanding, and other techniques are still in the development stage. And all those things towards accelerating the energy efficiency gain. Despite the hype around the progress of renewable energy, many people don't realize that solar and wind has only made a tiny dent in the energy mix. Thus, so far. The good news is that costs are coming down and many people are starting to adopt green technologies. But there is still a mountain to climb if we want to truly get off the fossil fuel on long run. Space-based solar power, tidal power, hydrogen power, magma power, and there is many power like waste power, embeddable solar power, algae power, flying wind power. All those things are in development stage, focusing to achieve higher efficiency. So we all think why energy efficiency can matter. Many of us know about the Apollo 13 mission. The astronauts were able to return after a failure to land in Earth, landing in Moon. With their lives hanging in the balance, the brave Apollo astronauts struggled to conserve the power. They reduced their power consumption, reduced their food, everything. And what happened? In the result, they were alive to reach Earth. Today, the number of connected electronic devices is 5 times higher than the population of the world, and the result is increased energy demands. It follows that energy efficient technology is essential to achieve. And with the massive projected increase in connected devices, there is a strong environmental motive to pursue energy efficiency. The International Energy Agency refers that energy is the world's first fuel. Energy efficiency is one of the most important tools for avoiding climate changes by reducing use of fossil fuels. How is the energy efficiency getting visible? You can see the size of AC/DC power converter reducing in size every year. If you think about a 5 ampere AC/DC power converter that was in 1950, it has a larger transformer, bridge rectifier, large filter circuit, and a 3-inch or 4-inch cooling fan. The weight was approximately 3 kg. After the invention of personal computer, size of converter started to reduce dramatically. The most important transition was PWM converter to SMPS converter. In a switching mode power supply, the low frequency transformer replaced with a smaller high frequency transformer. And nowadays, solid state power converter has invented, and the size of a 5 ampere 5-volt converter reduces to inches, and the weight is less than 100 grams. And what about the efficiency? It has improved from 30% to 99%. The example will be more clear if you think about the size of the charger of your first iPhone, say iPhone 1. And the charging time. Now, after 12 years, the charger size and weight reduces to half, and the efficiency improved to 97% from 80%. Also, if you think about the battery, the size of a 100 ampere hour lead acid battery and the size of a 100 ampere hour lithium iron phosphate battery, physically the size reduces to 30%. Ease of accessibility has improved to newest dimension. Thus, we are buying modern electric cars in same price of petrol cars. So why the efficiency has counted during designing. Can you imagine? The first thinking was to reduce the size. Unless reducing the size, ease of accessibility cannot be improved. If we think about the television, mobile phone, computer, laptop, etc., we can easily get the ideas. So the future, of course, is the sustainable energies, and there also should have the energy efficiency in the designing stage of the product and also in the system. Likely, the solar panel, if we see the solar panel efficiency has improved a lot. The price has dramatically reduced. The first cell invented in the first cell invented, its efficiency was approximately 6%. Even I used the first solar panel in 2009, a 20-watt polycrystalline solar panel. Its efficiency was 11%. Now the panel we are using its efficiency at 21%, and we heard the cell of 46% efficiency already invented. So all these things are very important. I am now I will describe how the efficiency improvement done in my work in my previous companies or in my recent employment. I have been working with Global Leap Award since 2014. The Global Leap Award is an international competition to identify and promote the world best off-grid appliances, accelerating market and development and innovation. Since 2016, the Global Leap Award has hosted competition to identify best-in-class off-grid fans, TVs, refrigerator, cold chain technologies, solar water pumps, and electric pressure cooker. The Global Leap Award identified the winner and finalist through a competition of, and they test the product in accredited laboratories. Likely in last 6 years, 6 of my products that were developed by me were winner in 3 other competitions. In 2015 and 15.6-inch off-grid television, that was the finalist in Global Leap Award. In 2016. I have 2 off-grid television. One was 19 inches, another was 22 inches. That was the winner in Global Leap Award. And in 2019, there were 3 solar water pumps that we participated with, and we are the winner in 3 different categories. The each product was based on appropriately designed, highly engineering efficient application, as Sean was saying. How we were successful, I want to share the experiences with you. The first I will describe about the television. While we are comparing different brands of television, we found the efficiency of multiplexer power converter is different, and the difference is 10% to 15%. Then we focused on the TV power supply board firstly. We achieved the efficiency to 98%. This reduction, it reduces the power consumption of a 15.6-inch television, 15 watt to 12 watt. We also focused how to reduce the power consumption during standby operation. We were able to reduce it by 80% from 0.1 watt to 0.2 watt. So you think this is a very tiny amount of power, but it is very important. We used better heat sink and good quality material for PCB, which has half heat dissipation capacity. Also, which has the self dissipation capacity, and the heat dissipation capacity was just double than the previous. Also, while ordering the other component like LED panel, we set our own specification and guide the manufacturer accordingly. What's the result? We are finalists in the competition, and the Global Leap Award, we exported in 7 countries. Our sales improved to 200%. So the company was profitable, and everyone was happy to me and my team. While we started working with solar submersible pump and surface pump, we first set our target for to improve, for how we can improve the system efficiency. In case of solar pumping system, the overall system efficiency is very important. This is measured how much water discharging against the power consumption. The major component of a system are solar panel, pump, motor, controller, cables, and delivery pipe, which has contribution to the overall system efficiency. On solar panel cables and delivery pipes, the pump manufacturer has no control because the end user or system integrator decide this. So we focused on how to improve the electrical and mechanical efficiency. While working with electrical efficiency, we firstly identified the root causes of power losses. This is very common. You have to identify the root cause. In which stage you want to improve the efficiency, in why the losses is occurring, in which stage you have to improve it. We focused on the motor coil and increased the insulation level and reduces the resistive and inductive losses. Then we focused on how to improve the mechanical losses. We reduces the weight and thickness of the impeller, keeping the same load handling capacity. After that, we focused on the bearing, used the best quality bearing considering their operation underwater. Also, we improved the heat dissipation capacity of existing controllers. At end, we were able to improve the water flow only 10% higher at the same power than before. But this was a great achievement. We realized this when under Global Leap Award, the product were tested in the independent testing labs in USA. All three products we sent for testing was winner in three different categories. And our sales improved at this time also 200%. And we started exporting and research to 13 countries, whereas we had no export-based sales in previous. We only have sales in domestic market, but now we already reached to 13 countries. So this is a very big achievement. So this is how we improve the efficiency of the system and the product, and we won the award, and it was financially benefited to my company. So you can get some idea from here. And I want to talk about the solar home system, currently very popular worldwide, and the highest number of solar home system already installed in Bangladesh. Most of the solar home system are based on DC 12-volt loads. While working with solar home system in a Bangladeshi company named Solaric, we found the system voltage is 12 volt, as I was saying. That means the battery, the load, the appliances, all are 12 volt base, and panel voltage is accordingly. Then we found the resistive losses in load cables are too high. And to reduce the losses, everyone, the system integrator is offering to using cable of higher rating. This was increasing the system cost. Then the idea of implementing DC-DC buck converter using in solar home system came in our mind. We designed and developed the solar optimizer to improve the load voltage to 125 volt. It was a DC 125 volt, so a DC-DC converter, and the conversion efficiency was approximately 97%. It is almost equal to the efficiency of a solar charge controller. Actually, the DC buck boost converter, those efficiency are 90 to 95%. When we reach at 97% efficiency, then we found that this can be replacement of a solar charge controller to the solar home system. What were the result? The transmission losses in the cables reduces dramatically, and we were able to use load cables of minimum capacity. So the cable cost reduces dramatically. End users were able to use standard loads, like they can go as much distance as they want. Conventional AC/DC loads like LED light, fan, television, laptops, and can be used from the same solar optimizer. Thus, along with the solar optimizer based solar home system, the demand of standard appliances increased a lot. In a result, the revenue growth reaches to triple than the last year. Those entire things I describing because to focus on how energy efficiency is playing a vital role in enhancing the revenue of the company. End of the day, all innovation, what you are working for, you need to be keep in mind that all the innovation will be successful only if it can bring financial profits along with the other benefits. considering energy efficiency is not only the issue to consider during designing a basic product, also you have to consider it during designing the system. So it actually the system efficiency, when you improve, it will also reduce the prices of the system and it will increases the sales. And energy efficiency not only comparable for the component, but also for the system and the product in everywhere, every single component that have a demand to improve the efficiency. By improving efficiency in our product and system, we will be able to lead our art to a net zero carbon emission stage. So, since Davy, that was my speeches today. You can allow the other speaker now.
Thank you, Ershadullah. Thank you. It's great to hear the many methods you can use to achieve efficiency in a variety of products. I think that's really helpful for all the students trying to achieve efficiency in their own products. Particularly what you said about trying to achieve efficiency in all elements of the design. I think that's really important. Finally, we have Richard Atwal from Renewit. Richard, thanks for coming today. I can pass over the sharing of the screen to you if you like. Just give me 1 second, I'll close this. And feel free to go ahead.
Okay, I just need to open the file. 1 second.
Oh, no worries. I have it here if you prefer it that way.
Yeah. Oh, if you can, yeah, that'd be great.
Okay.
Yeah, perfect. Okay, so welcome everybody, and thank you, Sean and Emil, for inviting me today. And also thank you to the fellow speakers. It's really interesting to hear slightly different perspectives on the processes companies go through to make their products more energy efficient. Renewit is in a slightly different place. We're a manufacturer of product only. We started off in the off-grid solar industry about 13 years ago, where we tried to take part in the whole value chain, manufacturing the product, exporting it, importing it into countries, and being the final distributor. And part of the whole sort of efficiency process was we realized that we couldn't actually do every part of the process well. And we were much better off focusing on the element that we were good at, which is the design and manufacturing of the product. And we now solely do that. And we manufacture for brands and other companies who distribute off-grid solar products, which is our key business. That focusing of the company was important. It was important because it made us realize that we needed to invest in R&D and product design and innovation ourselves. And it also was important because it made us really focus on one of the key drivers of the product, which was the pricing of it. And how did we keep our pricing competitive, where we were no longer selling to the end consumer, but we were now selling to a third or fourth or second party that maybe then were distributing the product on. Since that, we've even gone on to establish assembly plants for our products in country. So we've opened assembly plants in Ethiopia, where that product's actually made in country, which has been very successful. So we had to revise and revisit our design process. How do I move the screen on, Sean? Thank you.
Sorry, yeah, just let me know and I'll change the screen for you.
Okay, brilliant, thank you. So this is the design process we kind of go through now when we're looking at a sort of developing a new product. And this is what's really enabled us to make our product more efficient, price competitive, but also bring in some elements of the things that are important, like future-proofing the product to give it some longevity in the marketplace. And we kind of follow this sort of pattern. We look at the strategy, really focus that on who is our consumer for this product, and which is really important because the end consumer really is the driver of what the product will do. You know, often I've seen people go out and design product that they've overcomplicated for the end consumer, making it expensive and actually making it less efficient and not delivering what the consumer wants. And if we take something like a lighting system, where what's important to people is the brightness of the light, how long the light will last. But then as you look around different countries of the world, other things become important. In our markets in West Africa, the number of lights becomes important because of the way the domestic homes are set up. People want 4, 5, or 6 lights. Whereas in East Africa, we don't have that requirement. People are quite happy to have 2 or 3 lights, but they want much brighter light that lasts a longer time. So these are the kind of understanding your market is very important in driving the efficiency of the product. And that also goes for when people try and benchmark. Yes, it's important to benchmark against competitors and what other market exists, what other product exists in the market, but benchmarking against what the customer wants is actually probably more important. And we find that has become much more successful for us. We're going to go through an ideation stage, a design stage. And at this point is where we look at how we can make incremental improvements over time. So how have battery technology moved on since we last did a product? You know, what better battery performance is out there now? What better panel performance is out there now? How can we improve our circuitry? How can we improve our standby current so that battery drain is reduced during times when the product's not being used, when products going through the shipping process? You know, supply chains are very long now, particularly at the moment. It can, from the time we manufacture a product till it arrives on the shelf to be sold to a customer, can be over 12 months. And during that time, we need to make sure our product has retained power and the battery hasn't drained too low. And those type of efficiency ideas only come in when you understand the whole process of your product, from how it goes through the whole sales process. And that becomes very, very important. At the same time, you've got to be inventive. You've got to take risks. And this is your time to do that now at the ideation and the design stage. How can we make our product stand out? How can we make it perform better than anybody else's? How can we make it unique in the marketplace? You have time to rein it in. You know, when it comes to the actual engineering, when it comes to sourcing the components, maybe some of your wild ideas will be reined in a little bit, but you've got to put those ideas in now so we can actually really, really drive product development forward. And that's really important. Next slide, please. Another element that becomes very important is the certification and the qualifications your product may need. There are international certificates in the off-grid solar market that are now run by Verasol, which is the old Lighting Global World Bank program, and they issue certification, which is based around sort of IEC standards. But there are also several other certifications that can be required for your product, depending on the market it's going to in the world. So whether it's going into Europe and then you require CE markings and CE certifications, whether it's going to certain countries across Africa where you have maybe SONCAP and different regulatory import requirements. It's very important to understand that at the beginning of your design and manufacturing process. And that will also help you drive efficiency because it will give you some guidance to what's expected of the performance of your product. And these aren't targets, these are targets to be beaten, where you can actually then try and outperform the certification requirements. But it's very, very important to think about this now. The last thing you want to be doing is thinking about certification as a secondary thought at the very end of the design or development of your product, because you can end up, one, costing a lot of time and money to change, but also actually reducing the efficiency of your project. Next slide, please. This is just taking one of our oldest products, which was a solar lantern, which was designed to replace, in fact, we've had this in our range for over 10 years now. It was designed to replace the kerosene lantern. And part of the efficiency, or part of the reason this was designed, was that we wanted to future-proof it. So as technology improved, we could actually do different versions of the same product, but using the same outer casings to save us time and development costs and so on. So over the time we've been running this product, it's now about 30% cheaper than when we first sold it. And it's about 50% better performing in light time, battery time, panel size, everything. So it's an incredible change in the sort of cost and quality of the product. And also as technology's improved, battery sizes have shrank, LED sizes have shrank, and so on, we've actually been able to do 2 or 3 versions of the product from the same casing. And that becomes important in the future when, you know, we had customers who were bidding for tenders. These tenders all had different requirements. One maybe required a battery size of X, another battery size of Y. And we could actually do that quite easily and respond to our customers' demands by using the same actual product casing, which saves a lot of time and money. And it's also enabled us to keep up with technology as it's moved on. We haven't had to keep redeveloping our product as batteries have changed. We've been able to integrate that new technology into the existing product. Next slide, please. And that then goes for a range of systems as we've brought in other products into our portfolio. So as we've moved into appliances like televisions and fridges, we've been able to work with the manufacturers, one, not only to improve their energy efficiency. So when we first went to TV manufacturers and said to them, look, we're looking for a TV for the DC market of Africa and India, they weren't that interested in supplying us. They didn't see that it was a big market. They were happy with the business they'd got. And they actually, in the end, just gave us some TVs and said, you can do what you play with them yourselves. You tell us how to improve them. So not only converting them into DC for DC power, but also looking how we can drive them to be more energy efficient. So very simple things at the beginning were done that enabled us to bring extra power to the system. So just by turning down the brightness a small amount, we could give an extra hour's running time a day for the television from a small battery. And those sort of incremental little changes we were doing all the time enabled the product to become successful in the market. Now the TV manufacturers themselves are working on those technologies because they see the market opportunity. And the same goes for cooling, for refrigeration. It's taken time, but the actual manufacturers now of the fridges are seeing the opportunity, and they're coming up with ideas and ways of making their product much more efficient. So, for example, having a simple thing like having a door at the top of the fridge rather than a front door style fridge improves efficiency by 20%, which for a brand like Coca-Cola, when they're using fridges in all of their little stores, is really, really important. Domestically, we may, consumers still may want a traditional front door opening fridge, but commercially, we've enabled ourselves to use these sort of top opening fridges and really, really improve efficiency. Next slide, please. Sorry. Sorry, excuse me. I also want to talk to you about a little case study of things that we've worked on. And this is about using our product in the aid and development sector. So previously, when our product had been used in sort of aid and development, it was just taking existing product that we were selling, selling commercially, and then using it to try and meet requirements of people in the aid and development sector that maybe were displaced, maybe living in camps, and maybe refugees and so on. And it was really a case of shoehorning product into that market just to help the market. And it didn't really work. The product wasn't efficient for that marketplace. And to give you an idea, it was things like, how do you hang a panel in a camp when all you've got is a tent and there's nowhere solid to hang the panel? And those type of sorry, excuse me, Those type of problems weren't being answered by the sector, and actually the product that was going wasn't 100% suitable for its requirements. And part of that efficiency again was understanding the client's needs. How do we make the product more suitable for that market? Next slide, please. So the type of things we did were we got much more involved in the idea process at a very early stage. What is a camp situation like? How do people actually use the product? What do the people in the camp want the product for? And then therefore we could do we could develop solar panels with hanging fittings that would work on tents and temporary structures and so on. Look at what was required for different groups of people in the aid and development sector. So people in camps that were going to be there for many years have a very different somebody fleeing a war zone and so on. And ultimately, we're keeping things simple, keeping our product so that it could be repaired easily if required, as that was quite difficult to do in these sort of very disorganized areas. And that's something that became very important. I advise you all finally to really keep on top of the industry bodies that are involved. So whether it's the Energy Saving Trust, Efficiency for Access, but there are other bodies that are really important. So Verisol, which is taking over Lighting Global, is a very important body for you to follow because it shows you the idea of the level of certification required for your product. Also follow Gogler, which is a sort of industry spokesperson body of the industry, and they have various papers on their website of research of various products and performances. There's some newsletters like Sun Connect News that comes out twice weekly, and there's an organization called CLASP that has various papers that are important as well. And that's it. And good luck. Thank you.
Thanks, Richard. Thank you. I think you covered a lot of ground there that I think would be really useful for the students, figuring out where efficiency fits in the whole process, and understanding a market and how efficiency feeds into that. Just lots of great things to cover. We're almost out of time, and we don't have our attendees today. I think it must have been an issue with the invitation system, but this all goes online, and people watch it for the coming years as well as this year. We do have some questions for you all if you're open. I think first we have a question from Mr. Shehryar to Mr. Ershadullah in the chat. So Ershad, would you like to respond to this question? I can read it out to you.
Yes.
See it.
Yes.
For small 100 to 300 watt power DC systems, are DC-DC converters cheaper compared to charge controllers in the medium to long term, and why aren't more suppliers using them? So thank you, Sheriff, for the question. Ershadullah, would you like to cover that?
Okay. As I already mentioned, the optimizer we designed based on considering the efficiency, and we found the maximum capacity on 130 watt that can be achieved 95% efficiency. If we go higher, the transformer size need to be in bigger size. Like here we use high frequency transformer, and as I told, it is a buck boost converter. So there is switching mode power supply. So once I trying to increase the capacity, the number of MOSFET and number of transformer increasing, so the efficiency decreases a lot. That's why we went up to 130 watt, and including the price of the load, the prices of the system is lower than the conventional solar home system. So the answer is for 300 and 400 watt, this type of DC-DC converter, we did not found good, and we did not went in those way. I think you are clear.
Thanks, Ershadullah. And I saw Shehryar acknowledge that in the chat. So thank you for your answer. I mean, before we move on, I think we're just about out of time, but did Jackie or Emil have any questions, just in case you covered any, you can cover anything that a student might ask they're present?
Well, I do have one like more general question, but it's aimed towards Richard, actually. So you said during your presentation that the main driver for the product design is the end user. So how do you decide on like what factors to prioritize if you also want to focus on efficiency, for example? So do you always put the customer first, or will you sometimes overrule a customer's demand based on your own vision for a product? Like if you want to improve efficiency instead of your design features, is the customer always right, or should you, stay focused on your own product development?
It's a good point. I mean, the customer isn't always right, mainly because obviously if you give customers options for product, they will keep telling you to add the option without realizing the effect on the efficiency of the product. So there is an element where we do take control of that. It's more about understanding the customer's user case study, how they use the product, which becomes really, really important. And that's the bit that we needed to work on to make our product more efficient. So how long they required light time, how long they required fan time for, how long they required TV time for. That bit is the bit that we were missing initially in our sort of design process, how the customer actually used the product, and understanding that fully enabled us then to make our product more efficient for the customer use. But yes, you're right. If the customers demand that we add a microwave and add a mixer, and then obviously we have to draw a line at that point and say this is impossible to do now and keep our product efficient. So it was more about us understanding how the customer actually touches and uses the product.
All right.
Thanks, Richard.
Thank you, Richard.
And thanks, Emil, for your question. Okay, just running out of time now, but before we go, I wanted to cover that we have an upcoming webinar, another one on the 4th of November, this coming Thursday, on social impact and social inclusion. So we have a great panel of speakers lined up for that as well. So please attend that. If you're watching this in post, apologies to those who weren't able to attend, but this will all be available online. Hope you found this all useful. I'll just run through these final slides for people to fill out this feedback survey once they finished watching the webinar. Please just visit this. It'll take a couple minutes to fill out. That's our feedback survey. Leave that on the screen for a moment. And finally, the newsletter sign up. So if you aren't part of the newsletter already, please get signed up. We have all sorts of important information on there, including information on our webinars. And that's it. Thank you to all of our speakers for coming today. Thank you, Richard. Thank you, Ershad. And thank you, Shehryar. It's been a pleasure to hear everything about efficiency and all your experience and expertise on that. And hopefully this is useful to the students. And I'll get back to you if there's any further discussion on the CrowdSolve page. Everyone, please feel free to get engaged there about the topic. But in the meantime, thank you all for coming, and have a nice day.
Thank you, everyone. Thank you, Sin.
Thank you. Bye-bye.